This is checkpoint 2.25. We're given a vector v, and they want us to find the angles formed by the vector v, in each of the coordinate axes, or the standard basis vectors in the coordinate axes, the I and j and the k. All right, we're going to use our formula. Let's write v first. V is equal to +3, -5, and +1. And then let us recall, just for our sake, try to recall that the angle between them, theta, if you remember, is our cosine of the dot product between the two vectors, and then we divide by the magnitude of each. Okay, so that's our formula. If we're going to do this for I, j, and k, our standard basis vectors, then we know that the magnitude of I is equal to the magnitude of j, which is equal to the magnitude of k, which is equal to 1. So let's keep that in mind, that one of our calculations is going to be just 1. Also, if we do the I dotted with v, or v dotted with the I vector, is going to be 1, 0, 0, so it essentially wipes out the y and the z components, and it'll just give you 3. And then v dotted with j is going to give you the middle term, the y term, and v dotted with k is going to give you the last term. So those are just little pieces of information that would help us kind of expedite our calculations. Instead of doing, we want to find the angles between v and I, j, and k. And so we're going to do these computations, but if we keep this in mind, then we're going to be able to run through it a little bit quicker. Now, the last thing that we probably want to do before we even get started is to figure out the magnitude of v, because that's going to come up in the formula. And the magnitude of v is the square root of 3 squared and 5 squared and 1 squared, and that's going to give us a square root of 35. Okay, I think we should be all set now to figure out the angles between the vector v and the axes. Let's start off with a, that's v, and I want to put a dot product there, v and the I vector, so along the x-axis. And that's going to give us theta is equal to the arc cosine of v dot I, that's going to give us a 3, divided by the magnitude of v, which is square root of 35. And remember that the magnitude of ijk is equal to 1, so we don't need, probably have to put that there. And then we get the arc cosine of 3 over root 35. And so this is some calculator work that you're just going to have to punch in. And when I did it, I got 1.039, which is approximately, actually this is also approximately, and but in terms of degrees, I got 59.5 degrees. Okay, so that's the first one. And the second one is along the j. And here we're going to get theta is the arc cosine. Now the j component, the dot product that we got, is really just the y component there, -5. and the square root of 35 again times 1, but I'm not going to put the 1 anymore. Now, we have a negative number in the arc cosine, and if you remember the cosine, it starts off with positive 1, and then it goes down until you get to pi over 2, which is 0, and that's why, you know, the dot product of two orthogonal vectors is 0. But then when your angle is bigger than 90 degrees, it goes into the negative side. And so taking the arc cosine of a negative number should mean that the number that we're going to get should be bigger than 90 degrees. And so numerically, or radians, we get 2.578. And so that's bigger than pi over 2, but if we translate that into degrees, it's 147.7 degrees. Okay, finally, C, we're taking a look at V and K. So our theta is going to be the arc cosine. Now the last component is 1. The magnitude of V is square root of 35, and the magnitude of K is 1. And this turns out to be 1.401, which is about 80.3 degrees. Okay, so this is our setup. These are the angles. If you want to take a look at this from a graphical point of view, you can plot this graph on the XY plane or XYZ space, and then find the angles between this vector and the X, and then the Y, and then the Z. Okay, I hope that helps.